Hello everyone and welcome to 7th grade math, module 1, ratios and proportional relationships. In this video we're looking at lesson 2, proportional relationships. Our learning goal is to determine if two ratios are proportional. This will help us master standard 7.rp.2a, which is to decide whether two quantities are in a proportional relationship. Well, let's start off with some terms you need to know. The first one is proportional. Relationships are proportional if all ratios are the same in simplest form or if the unit rates are equivalent. Now, we actually have a special term for that number that you get, that ratio, when you either simplify all those fractions or put those ratios into unit rates. And we call that ratio that is in common the constant of proportionality. We have a nice simple little formula you can use to find it. K is the letter that represents our constant of proportionality, and you just get it by taking your ratio written as a fraction, y over x, and again either simplifying it or you can turn it into a unit rate, which is a different way of thinking of simplifying our ratios. Now, you might be wondering, why are we using y and x to represent the numbers in our ratios? Try to get used to thinking of these letters to represent these values because it's going to be a good connection to some things that you'll be learning in 8th grade with linear functions. Let's see if we can identify whether these ratios here have a proportional relationship. In the back of a recipe book, a diagram provides easy conversions to use while cooking. So looking at this diagram here, I see that they have cups over ounces and that the numbers are paired together. So those numbers that are paired together are going to make my ratios. We're going to use a constant of proportionality, or looking to see if there is one, to see if these ratios are proportional. So the first thing I would have to do is set these up as ratios. Well, I see a problem with my first pair of numbers here because I like to start on the left. We've got two zeros. We can't do 0 over 0 as a fraction. We can never have 0 as a denominator. And if I try to make a unit rate out of this to see if it's a constant of proportionality, I can't do 0 divided by 0. You can never divide by 0. So we can't see if this is part of our constant of proportionality, but I will let you know that we will be talking about in graphing the importance of having two zeros in a proportion. For now, it's good to know that it's just saying that when we have 0 cups, we have 0 ounces, and that's true. It would be really concerning if you said, I have no cups, but you magically ended up with some ounces. Where did that stuff come from? Did you get some extra flour that fell on the counter? So let's look at the rest of our numbers here. All we need to do is set up our ratios and see if they have the same unit rate. So to do that, I'm going to take my cups and divide them by my ounces. So all I need to do then is for my first pair of numbers after my zeros, my half and my 4, I'm going to take half and divide it by 4 and get a unit rate of 0.125, 125 thousandths. So that's 1/2 divided by 4, 0.125. I can do the same thing with 1/8. 1 divided by 8 gets me the same number, so I'm just going to set that as equal. It's a good thing that came out the same. Well, how about 1/2 divided by 12? Same exact thing again. Now, I want to make sure I don't stop here. I want to check every number, especially on tests. They like to hide the last pair of numbers as something where one of them is not quite proportional. So we can do 2 divided by 16. And it turns out that, yes, it is proportional. Whoop, that's not what I meant to write. 1 over 16. 2 over 16. So we can find that constant of proportionality, which we can either write as our unit rate of 125 thousandths, or we can write it as the fraction here that's in simplest form already, which is 1/8. So the ounces are proportional to the cups. Now, you can use what you know about equivalent fractions to look at these pairs of numbers and see if they're all equal to each other. That's easy to do with, say, 1/8 and 2 over 16. I know that 1 over 8, if I multiply my numerator and denominator by 2, gets me 2 over 16. It's a little harder to see with, say, a half over 4 or 1.5 over 12, but I can do 1.5 times 3 to get, 1/2 times 3 to get 1.5, and 4 times 3 to get 12. And I could also take my 1/2 times 2 to get 1, and my 4 times 2 to get 8. So all of these fractions, all these ratios, are connected to others that are equal to them. So now that we know that the ounces and cups are proportional from the back of that book, we can use that constant of proportionality, which we could either write as the fraction 1/8 in simplest form, or we can use that unit rate of 125 thousandths, and we can use those to help us figure out any missing amounts of cups or ounces if we know the other. So how many ounces are in 4 cups? Well, my first strategy that I can try is I can take that k equals y over x, and I can make sure that since I know that my number of cups, y, is 4, and I know my k, which is 1/8, I can just plug those numbers in for k and y and solve for x. I tend to like to use cross multiplication as a strategy here. So 1 times x is x, and 8 times 4 is 32. And since x is already by itself, x is 32 ounces. Sometimes, though, I find it a little easier just to do straight multiplication or division instead of setting up an equation like that. And I can use a simple fact family with multiplication and division to help me with that. So I drew a fact triangle that has k, y, and x in there with their relationships. So if I was trying to figure out what my ounces were, which is x, all I need to do is cover up x in my fact family, and it tells me I have to take my y number, which is 4, and divide it with my k. I like putting fractions in my calculator, so I did 4 divided by the 125 thousandths, and I got the same exact answer of 32 ounces. How about when we're looking for our y value, though? We can figure that out if we try to figure out how many cups are in 10 ounces. So if I set up my k equals y over x, my k is still 1/8. And this time, I'm going to keep y there, and in place of my ounces, x, I will put 10. Now, I could cross multiply here, or since 10 is the number I'm dividing my variable y by, I could multiply both sides of this equation by 10 like we did when we solved one-step problems. When I do that, I get y by itself, and it equals 10 over 8, which simplifies to 1¼ cups. Or I can use my fact family triangle to help me just use one operation and put it right in my calculator. So since again I am looking this time for y, I'm going to cover up the y. And it tells me that to find y, I do k times x. So I take my k number, again I like putting the decimal in my calculator, times our x value, which this time is 10, and it gets me 1/25, which is equal to 1¼ cups. So 10 ounces is 1¼ cups. Now, what does this video make you wonder about proportional relationships and finding if some relationships are proportional? Write your questions down so you don't forget them. Then you can try to find answers online, or you can ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.